Welcome to the Deep Dive. For this episode from Le Podcast de Philippe, we are tackling a concept that, frankly, sounds like it's straight out of science fiction.
It really does.
We wanted to dig into the sources on this thing called zero-point energy, or in French, énergie du vide.
Right, the energy of the void.
Exactly. And our mission today is to figure out, is this real, verifiable physics, a conspiracy theory, or something else entirely?
Well, let's start by grounding ourselves, because it's vital to know that zero-point energy, or ZPE, isn't fiction at all. It's a genuine phenomenon in quantum mechanics.
Okay.
It's basically the lowest possible energy that a system can have. You can even call it the inherent energy of the vacuum itself.
So our goal here is to sift through all the noise, especially all those free energy claims, and really get to the core of the science. We want to find that aha moment about what ZPE truly is.
And to do that, we have to understand the vacuum. And, in quantum field theory, the vacuum is not empty.
That's the first huge mind bender right there.
It is. It's the fundamental ground state of all these quantum fields, electromagnetic, Higgs, all of them, that fill all of space. Even with no matter, there's this constant fluctuating energy.
And this idea isn't even new, right? Our sources show this goes way back. We're talking 1913, 1914.
That's right. The concept of ZPE became probable then, coming out of work explaining weird anomalies in the specific heat of gases.
So what, they noticed things didn't cool down the way they were supposed to?
In a sense. They realized that even at absolute zero, systems had to retain some tiny amount of vibrational energy. And by 1916, Walter Nernst proposed that if matter has this energy, then the electromagnetic field filling empty space must have it too.
So if atoms are always wiggling, even when frozen, then the space they're in must also be wiggling.
That's a perfect way to put it. And the first real experimental proof for this came in 1924 from Robert Mulliken's work on the vibration of molecules. He measured it. It was real.
Okay, so the energy is there. It's everywhere. But how do we see it? What are the big observable proofs?
Well, it's responsible for subtle things like van der Waals forces. But the two smoking guns are the Lamb shift, and probably the most famous one, the Casimir effect.
Let's talk about the Lamb shift, because the notes here say it fundamentally changed physics. There was some kind of huge problem with the math.
A massive problem.
Yeah.
When they tried to calculate this tiny energy shift in an electron's orbit, the answer they got was, and this is the technical term, manifestly divergent.
Whoa, hang on. Manifestly divergent. For those of us who aren't theoretical physicists, what does that actually mean?
It means the result was infinity.
Infinity.
Yep. The math was telling them the energy shift should be infinite, which is obviously physically impossible. And Dirac himself said that solving this one problem, figuring out how to get a real finite number out of that infinite mess, fundamentally changed the character of theoretical physics.
Wow, so the moment the math broke, they had to reinvent the rules.
They did. And that reinvention, that new set of rules, leads us right to the Casimir effect.
Which is the classic visual proof of ZPE, the two plates in a vacuum.
Exactly. You take two uncharged, perfectly parallel metal plates, put them incredibly close together in a vacuum, and a tiny attractive force appears between them. It pulls them together.
And there's nothing actually on the plates, nothing pushing them. So what's the mechanism?
It's the vacuum itself. See, outside the plates, quantum fluctuations of all possible wavelengths can exist. But the tiny gap between the plates restricts them. Only certain shorter wavelengths can fit.
So it's like the plates are acting as a filter for vacuum energy.
Precisely. You have more energy modes, more fluctuations on the outside pushing in than you have on the inside pushing out. And that pressure difference is the Casimir force. It's a direct, measurable force from the energy of empty space.
That is just mind-bending. But it brings us back to that problem of infinity. If we can measure this force, can we calculate the total energy in the vacuum?
And that's where we hit the wall again. If you try to add up the energy of all possible frequencies of these quantum oscillators from zero all the way up to infinity,
You get infinity again.
you get an infinite energy density. It's a crisis point in the theory.
How does science even function when your basic calculation just explodes?
Well, you invent a fix, a brilliant fix, actually. It's called renormalization.
Which we touched on with the Lamb shift. This is the mathematical trick to get rid of the infinity.
It's more than a trick, but yes.
Yeah.
You develop a framework to systematically separate and discard the infinite part to get a finite result that matches what we actually observe.
It sounds a little like cheating, though. Like you're just sweeping the infinite part under the rug. What does that infinite energy physically represent?
Ah, now that is where it gets truly profound. The implication is that this divergent term, the part we have to renormalize away, actually contributes an electromagnetic component to the mass of every single atom.
Hold on, you're saying part of what gives things mass, part of what makes everything heavy, is this infinite background energy of the vacuum.
That's what the physics implies. It's a process called mass regularization. The energy of the vacuum is, in a way, responsible for the inertia of matter itself.
That has to be the aha moment. That the tool needed to fix the math of the vacuum accidentally ties that energy directly to the mass of everything we can see and touch.
And the sources back this up. They mentioned that the momentum from the Casimir effect isn't just allowed by special relativity, it's actually claimed by it. It solidifies that link between vacuum energy and fundamental properties like mass and inertia.
Okay, this is the perfect place to pivot. We've set up that ZPE is real, it's deep, complex physics. But because of things like the Casimir effect, this idea has been co-opted by, well, the free energy crowd.
And that takes us from verifiable physics into the world of speculative patents. We have a source here detailing a patent for a so-called zero-point energy power plant. An actual patent. What's the claim? How does it supposedly work?
Well, the language is creative. It talks about using magnets to create an ether energy vortex.
Ether. They're using the word ether.
They are. And this vortex supposedly compresses the ether's vibration until it becomes DC electrical current. It even claims the process moves tachyons and soft electrons through coils. Tachyons. Hypothetical, faster-than-light particles. So we've left established physics far behind.
Very far. And the inventor's claims are ambitious. They state that if this device wasn't suppressed, it would solve most, if not all, of the problems of our time.
Right, of course. A small device with no moving parts that would replace every engine on Earth.
That's the promise.
But let's contrast that grand claim with a dose of reality. Our sources also mention a YouTube DIY experiment.
A perfect counterpoint. An experimenter takes a standard car alternator, rips out the insides, and replaces them with 12 powerful neodymium magnets alternating the poles.
And during the test, it works, right? It generates a current.
It does. Enough to light up a 12-volt car headlight, which looks impressive on camera. But the experimenter's final conclusion is what's really important here.
What did they say?
After all the work, the conclusion was brutally honest. For me, it's fake. It's not parallelizable.
Meaning what?
Meaning the energy you get out never exceeds the energy you have to put in to make it spin. It's not creating energy from the vacuum. It's just a less efficient generator. He completely debunked the free energy premise of his own experiment.
And that just perfectly sums up the divide, doesn't it? On one side, you have the deep, rigorous science of ZPE that's so complex it breaks our normal math.
And on the other, you have these attempts to harness it for unlimited power that, when put to a simple real-world test, fall apart. The quantum energy is real. But extracting it like that is, for now, pure speculation.
So here's the final thought for you to take away from this. The vacuum of space is not empty. It is a violent, buzzing sea of energy that is so fundamental it literally contributes to the mass of every object in the universe.
That's confirmed by real subtle effects, like the lamp shift and the Casimir force.
But the leap from that profound theoretical reality to a device on your table that gives you unlimited free power, well, that remains a giant chasm that separates verifiable physics from these extraordinary claims.
And that leaves us with a fascinating question to think about. Given that the Casimir effect seems to fit perfectly within special relativity, what does that really imply about the connection between the vacuum, mass, and inertia? If the energy of empty space dictates how heavy things are, what else about our universe does it dictate?
A question to keep you up at night. Thank you for joining us. This was a deep dive from the podcast to Philippe. If you found this as fascinating as we did, please share it. Help us continue this exploration, share this deep dive, and help us reach 2,000 subscribers.